So research has indicated that the sea level has risen about 25 centimeters over the last 150 years, with an accelerated rate in the more recent years. So future projections show that the rise in this century, so the 21st century, could be up to 2 meters, as you're seeing here in the worst case scenario. Although this scenario is unlikely, it is also unlikely that this lowest or best case scenario can happen as well. So this lowest sea level rise scenario of the image that you're seeing in the slide is of an estimated 20 centimeter rise over the remaining of the century. And given more recent sea level rising rates, it appears more likely that the rise in sea level will be somewhere in between the two. So the effects of global warming are most pronounced in the high latitudes of the northern hemisphere. Now, for more than 30 years, the extent and the thickness of sea ice has been rapidly declining, as we know. Also, the permafrost temperatures have been rapidly rising. So what that rise in temperature means is that the areal extent of land, which typically contains permafrost, is rapidly decreasing. The alpine glaciers and the Greenland ice sheet have both been shrinking, and also the vegetation, which usually could not grow in certain latitudes, now can grow in those higher latitudes. So the extent of this vegetation growth change in the last 30 years is of 400 to 700 kilometers further to the north. So a very large areal change in the type of vegetation that is now more accustomed to warmer climates, which are happening further up north. So in the image above and to the left, we see the clear and dramatic loss of sea ice in the northern hemisphere. So the blue-reddish figure that you have right here shows the extent of the ocean waters that were covered by sea ice during September of 2016. And it compares this low to medium minimum of sea ice that existed from the years of 1981 to 2010. So this would be the extent of the sea ice at the minimum stages during those 29 years versus the minimum stage of 2016. And the graph that you have right here on the right part shows the very clear decline throughout the past 4 decades. And this shows that although some of the years the sea ice covers greater extents than others, so for example, there's a big change here in what seems to be 2011 or so, the overall trend is that there is a decrease in the ocean waters which are covered by the sea ice. The loss of permafrost is also a cause for concern. Permafrost is basically the frozen ground that occurs in portions of the high latitudes of the northern hemisphere. So this would be like the one that you see in the top right image right here. A great deal of evidence suggests that the amount of frozen ground has been decreasing in the past decade or so. The loss is actually so great that some models project near-surface permafrost to fully disappear in Alaska by the end of the century. The loss of permafrost is also a positive feedback mechanism that may reinforce global warming, unfortunately. So, when the vegetation of the Arctic Circle dies, the colder temperatures and the freezing that occurs will inhibit the decomposition of the vegetation that dies. So as a consequence, over thousands of years, a huge amount of organic matter that died has been stored in the permafrost, but it hasn't decayed, it hasn't decomposed. It has simply died and, remained frozen. So when the permafrost thaws, the organic matter that was frozen comes out of this cold storage and it will start decomposing. And remember that when one of the secondary effects from decomposition of organic matter is the release of carbon dioxide and methane. And that release is what you're seeing in the image here on the lower right, for example. But by the release of these greenhouse gases, the overall contribution of the organic matter that is now decomposing will in turn contribute to the warming of the lower atmosphere. And hence it will reinforce the cycle of temperature increase. The human-induced increase in the amount of carbon dioxide as well as other greenhouse gases also has a very large implications for the ocean chemistry and for marine life. So studies show that about 1/3 of the human-generated carbon dioxide ends up in the oceans. That's a very big amount. And remember, 45% remain in the atmosphere, which means that the remaining percentage is usually used by vegetation. So this additional carbon dioxide to the oceans will lower the ocean's pH, which makes the water more acid. So here's a nice little graph showing you the type of the pH scale, I should say. So lower levels are more acid, higher levels are more basic or more alkaline. So as we've seen in the past chapters, when the carbon dioxide combines with water, carbonic acid is formed. So carbonic acid, which is this formula right here, will overall lower the pH, and it will change the balance of some of the chemicals that are found naturally in the seawater. The pH has already lowered about 0.1 since the pre-industrial times. And if the trend of CO2 emissions continue to be the same, it is projected that by the end of the century, the pH will have lowered another 0.2 pH. So this change has not happened for millions of years to the rate that we're seeing it, which is very worrisome. The changes in this ocean chemistry are actually making it harder for certain species to build their hard parts, which are made out of calcium carbonate, as we saw in chapter 7. So these species are threatened because they can't use the elements the same way they would. The chemistry of the ocean is changing, and they can't secrete this calcium carbonate as easily as they would before. So species like microbes and corals are being threatened. And this is worrisome because they are a key habitat of many other marine life that is dependent on the health and on the availability of these calcium secreting organisms. So change is occurring. The climate is not predicted to be stable in the coming century. Climate was actually relatively stable during the past millennium as far as the measurements that we have, that proxy data that we have. But based on our projections, which are based on the observations, we don't think that the climate will be stable in this coming century. And depending on our decisions, maybe not later as well. So from many scientific observations, it is thought that the amount and the rate of future climate shifts really depends primarily on the current and the future human-caused emissions and of the heat-trapping gases and airborne particles, or of them. Many of these changes may be slow, and they may be nearly imperceptible from year to year, but when we accumulate the changes over decades, they will actually have a very powerful political, social, and economical consequences. And despite our efforts to understand the climatic changes, we may still be surprised by sudden changes. So abrupt climatic changes have been known to occur in the past, and again, we know this thanks to the climate proxy data that we have. So there is always the possibility that these abrupt changes can happen again, and that humans or other species may not be able to adapt fast enough to the changes that occur. So it is up to policymakers and to us ultimately what we do to try to help with these climatic changes that we are observing and we continue to expect. We must face the fact that Although our understanding of the climatic processes and effects has many uncertainties and that it's imperfect, we must work to minimize the risks that are associated with the continued human-generated greenhouse gas emissions. And we must also know that climate-induced environmental changes cannot just be reversed quickly. It will be a matter of decades or centuries. So some of the things that we've already started to do to counteract this are geoengineering. We have been trying to use more renewable energy and natural gas as opposed to much coal use, for example. And we have also used more efficient use of the energy through buildings, through lights, through highways, heating, cooling systems as well. So overall, we do have a long way to go, but there are things that we can do individually and as a community to also help reduce our carbon footprint in this planet. Starting with becoming more aware of the problems and also making others aware. And when we do this, we should always be respectful and never assume that we know more than we actually do know. So acknowledge what we don't know, but state what we do know. Also, I wanted to give you this website. It's very cool. I recommend that you go on it and check your carbon footprint. So if you input the different parameters based on your activities now, it will give you a specific carbon footprint, and it will tell you how many Earths as we know them will you need if everybody kind of lived with your life habits or your habits. And after you do this initial input of the current carbon footprint or of your current habits, I encourage you to go again and change some of those parameters that are asked by inputting changes that you could actually make in your life. I've done this a few times because I do this activity for my natural hazards class, and I think it's very good. And every time that I do it, I try to reduce different parts of the parameters, and I think that I am reducing my carbon footprint a little bit every time I change it. So as always, I hope that this lecture was good and that you enjoyed it. And please let me know if you have any questions.